Now, I want to demonstrate to you how to use IBM SPSS to do the ANOVA repeated measurement analysis. So in this example, you have two groups, experimental group and treatment as usual. Okay, and these are the scores that we receive before the test, 6 months after test, and 6 weeks after the test, and 12 weeks after the test. Okay, so these are actually the score of anxiety. Anxiety during the pre-test, anxiety during this test 6 week, anxiety after test during test at 12 week, right? So now we have three different intervals that we are looking at, and we have two groups. Okay, so to perform this, similar to factorial ANOVA, we don't really bother whether the data are normally distributed or not, because the algorithms are actually robust enough to factor that out from our assessment. Okay, so to do this, it's simple. You click analyze, you go to general linear model, you go to repeated measures, right? So the factor that we're looking at is actually time. So how many levels do we have? We have 1 pre-test, 2 test 6, test 12. So we have 3 levels. Okay, so you click add and then define. So now transfer anxiety pre-test at number 1, number 2, and number 3. Okay, then the group of treatment into between subject factors. Right. Don't change model and contrast, retain as type 3. Okay. Click plots. Okay. We want to see the independent as well as the interaction between the two factors. So click group into horizontal, click add, and then time into horizontal and click add, and then group into horizontal, time into separate lines and click add. Now we can see the individual factors as well as the interaction between the factors. So click continue. So click post hoc. Do we need post hoc? We don't need post hoc. Why? Because we only have two groups, experimental and treatment as usual. But if we have more than two groups, yes, we require post hoc test. Okay, so because of that, we just click continue. Then you click option, right? So we want to display overall, group, time, and the interaction. Of course, we want to compare the main effect, the group, and time. So we choose again Bonferroni. I click descriptive, homogeneity, as well as effect size. So click continue and then click OK. So these are the results, the outputs of the ANOVA repeated measurement. All the descriptive statistics you can read your own. Here you have box test for equality of covariance, although the p-value here is actually less than 0.05, indicating the differences in covariances. But this is not actually a big matter here, because as I mentioned, the algorithm is already robust enough to factor this out. But just to keep in mind that the variances are not the same. So then if you go to multivariate test, we have all the different data here. I would rather go for the first one. This is according to preference. I will go to Pillai trace. So you can see that for effect of time, it is actually a significant factor, right? Very significant factor. And it's accountable for 62% of the covariances. Whereas the interaction between time and group, they are not actually very significant. It's actually not significant at all, 0.652, and it's only accountable for about 4.9% of the covariances. So we know that time is actually the significant factor. Now, look at the Moseley's test of sphericity. Okay, this is, look at the p-value, it's 0.50. The value is higher than 0.05, meaning that we can assume sphericity of the data, meaning the data are actually in sphere. So it's sphericity. So why do we need to know this? Because we want to read down there the table. When we assume sphericity, we can read from the upper part of this table. If the sphericity is not assumed, I would rather go for greenhouse gaser. Okay. So in this example, the sphericity can be assumed. So we look at time, it's 0.000. Time versus group, it's 4.663. It's not significant. Okay. So if we look specifically at time, Of course, group treatment doesn't really make any difference. Group doesn't make any difference. 0.504. So it doesn't matter which treatment that. So in other words, it doesn't matter which treatment that you give. What matters the most is the interval. Okay, what matters the most is the interval of treatment, whether it's 6 weeks or 12 weeks, right? So you go down and you can see the time. Okay, pre-test versus 6 weeks, it's statistically significant. Pre-test versus 12 weeks, it's statistically significant. 6 weeks versus 12 weeks, it's not statistically significant. So in other words, there is no significant difference between 6 and 12 weeks. So it's adequate if we stop the treatment at 6 weeks only, not to prolong to 12 weeks for economical reason. So that's how you can interpret the data. As for the group, it's not actually they are not actually significant.